Welcome to this eLearn security training video lesson on idle scan. In this video, we will see how to perform an idle scan with two of the most known and used tools, nmap and hping. An idle scan is one of the most famous techniques used to perform a port scan without sending packets to the target host containing the attacker IP address. As you can imagine, this technique is very stealthy since the target host will never know the real attacker IP. All it requires is a third-party host, called zombie, which the attacker will use to bounce the scan. This technique will be clearer in a few moments as soon as we start using the previous two tools. For now, it's important to know that every packet sent or received in the network has an ID that uniquely identifies fragments of an original IP datagram. This means that if this ID is not available, the destination machine wouldn't be able to reassemble a packet datagram. The problem is that some operating systems have a predictable IP ID, since they simply increment by one number for each packet they send. As attackers are able to probe those systems, they can verify the IP ID header and understand how many packets the target system has sent since the last probe. Moreover, it's important to remember that a TCP communication works in a way where a client sends a SYN packet to the remote host port. Then, if the port is open, the server replies with a SYN ACK. Otherwise, it sends a reset. Moreover, when an unsolicited SYN ACK packet is received, meaning that there was no SYN packet previously in the communication, the operating system automatically replies with a reset packet. The way an idle scan is performed can be separated into three steps. First, the attacker sends some packets to probe the ID of a candidate zombie machine. We call these machines zombies because of their inactivity on the network. If during the probe the machine increments its IP ID by 1, we can consider the machine a good zombie candidate. Then, on the second step, we send a SYN packet to the target machine, the one we want to scan, by spoofing the zombie's IP address. This means that the target host will see the packet coming from the zombie host. At this point, the target will reply to the request by sending a packet response to the zombie machine. This will be a SYN ACK if the port is open, or a reset if it is closed. While we send these packets, we keep monitoring the IP ID of the zombie. If it increments by 1, then the port on the target is closed. If the IP ID increments by 2, the ports on the target are open. This happens because if the target replies with a SYN ACK, the zombie has to send a reset packet and its IP ID increments. Thus, we will know the port is open. Most of these steps are already automated with tools such as hping and nmap. Let's see how we can run an idle scan with hping first. First, we open Wireshark and set the filter to capture all of the requests going to or coming from our IP target. In our case, we will intercept the traffic on tap 0. Then, we open the terminal and execute a SYN scan at port 135 against the zombie candidate. Notice that we already know that port 135 on the zombie is open. Moreover, we use the -R option to relativize the ID field and estimate the host traffic. In other words, hping will show the increments on the target IP ID. As we can see, our host is a good zombie candidate for our idle scan since it has a +1 increment on the ID. This means that the host is not communicating with any machine on the network but us. Now, we have to send a SYN packet to the target machine. As said before, we have to spoof the zombie's IP. If the target is open, there will be a communication between the zombie machine and the target machine. To execute the SYN scan with the zombie IP address, we have to use the minus parameter followed by the zombie IP address. Then we set the target IP address and the port we want to scan, in this case, port 23. To see if the port is open, let's go back to the other terminal window to see if there is any ID increment by 2. Indeed, we can see that our zombie's IP ID incremented by 2, which means that port 23 on the target machine is open. From Wireshark, we can see part of the communication between the hosts. The SYN packets are sent by us to port 23 of the target in order to determine whether the port is open or not. Notice that since we spoofed the zombie IP address, the source IP is the zombie IP. The SYN, SYNAC, and reset packets sent and received on port 135 are the packets sent to the zombie in order to detect and monitor the ID increments. Let's now see what happens when trying to probe a closed port. For this example, we will use a random port that we know is closed. For example, let's use port 200. We will set up again the SYN scan, and at the same time, we will relativize the ID field and estimate the host traffic by using the -R option on port 135. Then, we will again perform an idle scan on port 200. As we can see from hping, the ID doesn't increment. Thus, we can infer that the port is closed or filtered. From Wireshark, we can see the outgoing and incoming connections between our machine and the zombie. Again, the reset packet is the response to our SYNAC packet sent to determine the IP ID of the zombie. The other SYN packets were sent again in order to determine if port 200 is open. This is how we can perform an idle scan with hping. We suggest you try the same technique in order to fully understand how it works. Another tool that we can use to perform idle scans is nmap. Among its great and countless features, nmap also offers the ability to detect good zombies and perform idle scans automatically. In order to detect if a host is a good zombie candidate, we can use two methods. The first official method was designed to specifically identify if IP ID is incremental. The second, instead, performs many other operations, but it also detects the IP ID sequence status. Let's see how they work. The first method uses the so-called NSE, which stands for Nmap Scripting Engine Script. NSE scripts are written in a programming language called Lua, which performs specific actions rather than just scanning, discovering hosts, and so on. For example, they can be used to perform a more sophisticated version detection, detect and exploit vulnerabilities, and much more. There are dozens of scripts, but we will not explore all of them here. For now, we only need to know that nmap offers a script called ipid-sec, which automatically checks if a host is a good zombie candidate. In order to instruct nmap to use a script, we have to specify the script argument, followed by the ipid-sec and the target IP. We can use an open port to get a more accurate result. As we can see, the scan completes, and at the end, we can see the script output indicating the IP ID sequence is incremental. Thus, this host is a good zombie candidate. The second method to detect if the host is a good zombie is by using its OS fingerprint scan. If we run this in a verbose mode, nmap will print if the IP ID is incremental or not. To do this, we have to execute nmap with two arguments. The first one is -O, which will start performing an OS fingerprinting scan. The second option is -V, which stands for verbose and runs nmap under verbose mode. Although it's not mandatory, it is recommended to specify an open port for our OS fingerprint scan. We do this because it will take less time to finish. It will simply avoid running a full scan on 1,000 ports and will focus only on one single port. In this example, we will use port 135. As we can see from the port scan results, nmap successfully performs the scan and detects the IP ID status as incremental. This makes our machine a good zombie candidate. Now that we've found the candidate zombie, it's time to move and execute the idle scan. Differently from hping, we will run one single command, and nmap will print out whether or not the target port is open or closed. So we will not need to detect if the IP ID increments, since nmap will do it for us. In order to run an idle scan with nmap, we have to use the -I option, followed by the zombie IP address. As you already know, in order to monitor the IP ID increment, we have to use an open port on the zombie. To specify the port, we can use a colon followed by the port number we want to use. In our case, it will be 135. Now that we have set the zombie, we can continue the command by adding the target IP address and the port we want to scan. Notice that we can also set more than one port here, but for now, we will focus only on port 23. Before running the command, we also have to add the -PN option in order to instruct nmap to skip the host discovery phase. Another very useful option that we can use here is the --packet trace option. This will print every packet sent and received by nmap, and will help us better understand what's happening. After the scan runs, we can see all of the packets sent and received. Once the command completes, we get the status of the target port. The first packets sent from nmap are used to detect if the zombie is a good candidate and if it has an incremental IP ID. Indeed, nmap discloses the host as a good zombie candidate. As we can see, the scan is finished successfully, and the port is stated as open. Let's repeat the scan to see something interesting. As we see, sometimes we may not stand lucky. Here we can see a closed, filtered statement of the port we are trying to scan. This might be a false negative, as we've seen with hping. From Wireshark, we can inspect the packets that were transmitted. As everything looks normal, the problem should probably be in the way that nmap tries to read the IP IDs of the machine. A nice approach here is to use both hping and nmap. We will check the IP ID with hping and perform the scan from nmap. This means that nmap will fake the source IP by sending packets from the zombie's IP against the target host at port 23. But at the same time, we will listen for any IP ID increment with hping. We first execute the hping syn scan in order to have a live view of the IP ID of the zombie. As we can see, the IP ID is still +1. Next, we open a new tab on the terminal and run the nmap command. Here, we call nmap with -S parameter, which tells nmap to fake the IP address. Then, we specify our target host and the port to scan, which is 23. We also have to add the -E parameter, which specifies the interface we would like to use for this scan. After the interface parameter, let's add the -PN argument to avoid revealing our real IP. And then the -- disable ARP ping option. We do this because we already know that the host is up. To avoid DNS resolutions, let's also add the -N option. By going back to the hping window, we can see that indeed the IP ID has been incremented. Thus, we are sure that port 23 is up and listening on the target host. Moreover, this informs us that sometimes manual checks may be more accurate than the automated one. Finally, it's important to note that as we can see from the Wireshark output, there is no captured communication between our machine and the target machine. This is normal, as this is the purpose of the idle scan. As you can understand, idle scan is a very powerful technique if we want to hide our real IP. Thanks very much for joining us.